Hello, my friends. This is Deepak, and I'm somewhere in the Middle East, not telling you where, but I ran into my friend, Leonard Mlodinow. Uh, Before I welcome him, just want to remind those of you who don't know, I first met Leonard at Caltech at a debate that I was having with some of his atheist friends. And during the intermission, Leonard got up, and I was talking about consciousness, and he said, "What is consciousness?" And I said, "It's a superposition of possibilities." And he kind of ridiculed that statement. He said, "I know what that is. It's not what you're saying." In any case, we became good friends. We ended up writing War of the Worldviews. We never totally agreed with each other, but we became friends. I would say that Leonard is one of my closest friends, and I value his friendship very much. And I feel very lucky to have met him. Although I don't believe in luck, I think it's synchronicity, entanglement, much to his annoyance. So anyway, Leonard, it's amazing to meet you here.
It's amazing to see you here too. It's the highlight of my trip for sure.
Oh, come on.
What a surprise.
And
we crossed paths
by
accident.
So you recently been very prolific in your writing. I want our audience to know a little bit, we're reaching a lot of people right now, a little bit about your last few books, Elastic and the other ones.
Well, I got interested. I'm a physicist, and I wrote a lot of books about mathematics, physics, cosmology, a couple books with Stephen Hawking. And then I got interested
in a book with Deepak.
And a book with Deepak, my favorite experience. And I got interested in the mind. And this is one of the interests that we share. And I had a friend at Caltech, Christoph Koch, who invited me into his lab, and I spent years there studying neuroscience and consciousness and taking the courses, going to the seminars, and ended up writing a few books, psychology/neuroscience books. The first was called Subliminal, about how the unconscious mind influences us and how we're not aware of that. And a lot of our decisions and our thoughts, our feelings come from the unconscious mind. And then I wrote a book called Elastic, which is about where our ideas come from. And recently, just this year, I put out a book called Emotional, all about emotions. And the point being that emotions are not counterproductive and something to be avoided or suppressed, that they're really a key part of our thinking, and they're entangled inseparably with our conscious calculations and our rational mind. You can't separate the emotions from the rational, and it's a good thing that you can't, because I talk about how they really benefits us in all our decisions making and thoughts. So that's what I've been up to lately.
So I've been reading his books, and they're very impressive, and they're all fact-based and science-based, and it's good to see Leonard exploring this realm of the abstract, so-called abstract, and giving us some scientific insights into the nature of emotions and the subconscious mind, which, as you know, in Eastern traditions is called the supraconscious mind, because it's eavesdropping on information that the conscious mind sometimes doesn't have access to. Would you agree?
Yeah, I think that's a better name, because it's your subconscious mind is more capable of complex analysis and good decision making than your conscious mind is. And a lot of the analysis that you think you're doing with your conscious mind is really just being bubbled up from your unconscious, where it was really done. So
the unmanifest. So Leonard, you've also been a writer of fiction, and I know you're doing a new book on fiction, but tell us something about your forays in that world of science fiction and media.
Oh, well, I've had a long and winding road, and I started out, before I wrote any popular science books. I was a physicist, and I left physics for a while and started working in Hollywood, and I wrote for shows like MacGyver and Star Trek: The Next Generation, and I had a lot of fun doing that. And then I went and made computer games for a few years, and then eventually went back to Caltech and back to science and writing science, popular science books.
And in your book, with what was it called? The Grand
Design
with
Stephen,
with Stephen Hawking, you actually, both of you came up with a theory called M theory.
Well, we didn't come up with that, but we based the book on that. Yeah.
So, I think they would love to know a little bit about what is M theory.
Well, M theory is the latest version of string theory, and string theory is a theory that is designed and hoped that, since it's not really worked out, but it's hoped that that will be the theory that unites Einstein's general relativity with quantum theory, and the theory of gravity with the theory called the standard model of all the other forces. And so string theory is an attempt to do that, and M theory is really just a more modern version of string theory. And what the book Grand Design was about was some of Stephen Hawking's work in the 2000s, which indicated that the universe could have arisen really from nothing in a way that comes from string theory, from M theory, and quantum fluctuations. So that the question of how did the universe begin, or where did it come from, really is answered in that sense by that. Of course, you could always say, where did those theories come from? So that in science, you can always put another Y on the end of whatever it is you discover, but it was another step in explaining how the universe got here.
As you know, Leonard has had a very distinguished career, also as a teacher at Caltech University. And I was reading recently and actually spoke to Sean Carroll on my podcast about his book, Something Deeply Hidden. And Sean is of the opinion, as you know, there are 35 interpretations of quantum mechanics, as we know, but Sean believes in infinite universes, in
many worlds,
even beyond that. He says there are infinite worlds, and the infinite versions of you and me in these different worlds. Something that I actually relate to, because in our Eastern cosmology, there are infinite worlds. That there's a phrase in Yoga Vasishta, which is a very ancient text: infinite worlds come and go in the vast expanse of consciousness, like motes of dust dancing in a beam of light.
Well, it does sound like modern physics. It does sound like
modern physics. So there is a lot of alignment in some of these ideas, although the terminology is very different, which brings me to the most recent Nobel Prize in Physics on entanglement. We were talking about it earlier, and our conversation started with the idea of entanglement, although we meant different things. What do you think of this? It's very well deserved. It's timely.
Well, it was a very important step to do those experiments, but we should probably take a step back and explain what the experiments were. And so in the 1960s, a guy named John Bell, well, let me go back even further. In Einstein, so in the 30s, Einstein, Podolsky, and Rosen wrote a paper analyzing a certain quantum experiment that they considered to be maybe ridiculous, or some absurdity that quantum mechanics predicts and actually does happen, which is that you can have in quantum mechanics, an object, it doesn't necessarily have a state of its own. Like Deepak has a physical state right now, I have my own physical state, and we're separate. We each have our own state with its properties. But in quantum theory, you can't necessarily say that about different particles. It could be that we're in a collective state, so that there's no single description of the Deepak state or the Leonard state, but there's just the state of the two particles. And that can happen in a way that we're even widely separated, but we're still in the same state. And if we're in the same state and you do some kind of measurements on me, it tells you something about the outcome of the measurements would have if you did them on Deepak, because we're in the same state and you disturb that state by doing a measurement on me.
What Einstein referred to
A
spooky
spooky action
action
at a
distance.
distance.
Yeah.
So people like Einstein and others didn't like that, but that seems to be what the way nature is. But then Einstein, being really smart, and these other guys, they had a proposal or an idea that, well, first of all, I should say Einstein did not think quantum mechanics was wrong, because as a physicist, he had to recognize that it worked. So in physics isn't a field where you go, but I disagree. If the experiment says something, that's the way it works. You can't argue with Mother Nature. But what Einstein did wonder was, maybe this quantum theory is a kind of illusion, or something that is just apparently how it works because of some limitations that we have, but that underneath the hood, or on a lower level, things work in a more reasonable way that he thought was reasonable, meaning the way that the regular world works. So maybe on another level, there's something else going on. And these are called hidden variables. There's something hidden going on that produces this quantum spookiness, but really isn't so spooky itself. And Bell realized in the 60s that there was a way to actually determine whether that's happening, or a way to rule it out. So he created some mathematical description which said that, talking about the correlations in the measurements, if you measure certain things on Leonard and certain things on Deepak, and what's the correlation? If you measure this on Leonard, does it always come out that way on Deepak, or does it come out that way half the time, or so forth? And so these are called Bell's inequalities. And
as a metaphor, you and I are doing a tango in, say, Rio de Janeiro, then you go to one end of the universe, I go to the other end. We're still in tango.
We're still entangled. We're doing a tango that's right. Or in this case, we met here.
Yes.
So as it turns out, you can experimentally test this. And if the experiments come out a certain way, it shows that this thing, the idea of Einstein's and the others, is not possible, that there are no hidden variables, and you can rule that out. And so people started trying to do the experiment, and that was what the Nobel Prize was given for, was that experiment, and showing that actually quantum theory, in a sense, is fundamental, and there's not other things going on. And so it was a very important thing to check and to confirm, and it had a lot of influence on people's thinking. So I guess it was worth the Nobel Prize. I personally have a couple other favorites that I'll throw in here, that I thought, if you're going to do a quantum theory or Nobel Prize, that a prize for quantum information that would honor Peter Shor and David Deutsch. If you've heard of those people, that I think that should be maybe the next year's prize.
So Leonard, what do you think of David Bohm's ideas on this? Because, when I read him a long time ago, he talked about something called the implicate order and the explicate order.
Pilot waves.
Waves. Then he indicated that, actually gave this analogy of a big fish in a tank. And every time the head moves, the tail moves, and you're looking through different windows. You think they're...
I've never delved deeply into that. I read a little bit about that, and it was not really interested in it. I think Sean Carroll might put more credence in that.
But Bohm was brilliant too.
He was, yeah. But again, this is another theory that the question is, if it's true, are there implications? Can you test it? And if you can't,
well, his metaphor was, there's a big fish in a tank, and if you're looking at it, all you see is the head here, and if you're looking from here, all you see is the tail. And every time that head moves, the tail moves. You think they're, two different things, but if you could see the whole thing, it's one fish. So the whole organism is the universe, where everything is inseparably entangled with everything else, but we're looking at it in a reductionist way. That was his idea.
Yeah, well, it makes sense for fish.
Yeah, it makes sense. Just like our entanglement makes sense for philosophers and not for scientists. Okay, now you have a new book on fiction. What's it about?
I'm writing a novel, a physics thriller.
Yeah, what is it?
I won't give away the plot yet. Also, I'm not sure if the plot is final, because I'm still working on it. But it's a very exciting book, and it's a book. I think of it as a kind of as physics fiction. So it's a novel with a great story, but it's about physicists and in the context, in the world of physicists, like you might read historical fiction about a certain period and you'll learn about that period. In my book, you'll read a book of fiction, but you'll learn about how physicists think and what their lives are like, theoretical physicists.
Lovely.
And so, yeah,
When-
we're very
when
excited.
does it come out?
Well, I'm hoping I'll finish it in the next few months, and then it's going to be another year till, you know how they are in publishing.
So Leonard's a very prolific author, and I look forward to every one of his books. And before I let you go, I have to ask you this question because it's been kind of bothering me for a while, and always a good opportunity to talk to a theoretical physicist who happens to be a mathematician too. All theoretical physicists are. So, I've been kind of tortured by that essay of Eugene Wigner for over a decade, the unreasonable effectiveness of mathematics. In physics, why does mathematics so predictably tell us about the laws of the physical universe? And, I've read all the commentaries and the remarks, and, a few days ago, I just woke up with this idea that actually it makes total sense. Math is an activity in human consciousness. It's a mental activity. It's a mental construct. But so is the universe, a mental construct for perceptual activity in consciousness. So they should correlate. I mean,
well, at least they have the potential of
correlation. Does that make sense to you?
Yeah, especially if you add that mathematics is a language that our brains can use to draw logical conclusions based on situations. And
I would not use the word brains, but that's all right.
Okay, what is doing it then? The consciousness. Okay, our consciousness.
With the correlated, the brain.
Whether you can say
it's all one thing anyway.
It's the same thing in my opinion. So our brains are also, or consciousness is creating our vision of the world. I don't think that the vision of the world is something that we just observe directly. It comes from the world to our brain, and that's what we perceive. I think some stuff comes to our brain. Our brain does a lot of processing and creates its own image of the world. That was in my book Subliminal. That was one big part of that, right? About how your brain is creating, your imagination is creating your physical experience.
The brain is creating
the
neurochemical correlates of the experience.
It's creating the world that you perceive.
There's no image in your brain.
But there is in my experience. So okay, that experience is being created, and it's an illusion, and whether or not there's anything out there or what the actual properties of what's out there is a separate issue. But anyway, I have a perception, and mathematics is something that my brain also uses to make inferences and draw conclusions, and physics is all about putting those two together to make a map from your perceptions to math, to build a mathematical model of what your perceptions are. And then your brain can go through the math to draw conclusions, to look at the future or the past, and you crank through that math, and then you map that back to the perceptual world, and you see what the world looks like in the future or the past. So that's how it works, but didn't really answer the question why it works. It has a potential of working because of what you said, but why does it work? Why does the universe behave that way? I don't think Wigner answered that question, and I don't have.
No, but your friend
answer.
David Deutsch actually has an essay on explanation and this human need to explain everything. And I read that essay. It was brilliant. And, in all honesty, there's no explanation for existence.
Then why was that essay so brilliant? Sometimes just to discuss the issue.
Or why we are here.
No, but I think there isn't.
It's the biggest mystery of our existence. And that for me is very humbling. And I think for you too, as a scientist.
Yeah, that's something we agree on.
We agree on. And actually the rest that we don't agree on, I think is a question of semantics. Because if mind, matter, consciousness, and the physical world are a unified activity, then it doesn't matter whether you call it brain, mind, or consciousness, or the physical world.
Fair enough.
On that note, please look out for Leonard's next book. What's the name?
That's a good question. Exotic Matter is the current name.
Lovely. Exotic matter. All matter is exotic because it's an illusion.
There you go.
Okay. Thank you, friends. Thank you,
Thank
Leonard.
you. Thank you.
I loved it. Were you okay?
Yeah, it
So
was.
let's give it a title. It'll be published in 2-3